Today we're going to start chapter 6, section 3, and we're going to be doing trig functions of any angle. So we're going to be using the unit circle. When we're talking about the unit circle, notice the word unit means one. So you can draw triangles just like we did when they were in degrees. However, our radius length, or our R value, is always going to be 1. Because if you look at your unit circle, no matter where I draw a radius in my circle, it's always going to have a length of 1. So if you look at the ratios over here that they're telling you to memorize for the 6 trig functions, notice sine is now just y. But if you think about it, what we memorized for sine was y over r. And now, when we're dealing with the radians in the unit circle, our r value is always 1. So really what went in here was y over 1, which just simplifies the y. So it makes it a little bit easier. The same thing for cosine. It was normally, you memorize it as x over r, and you can still do this. But again, remember your r value is always equal to 1 when we're talking about the unit circle. So this would have been x over 1, which is just x. Now for is, normally we saw theta here. So they're going to tell you which angle to find the 6 trig functions for. So let's say I said find sine of what we did before, sine of 30 degrees, and we drew the triangle. But what we're going to do now is we're going to find 30 degrees on our unit circle, and all we have to do is look at the associated order pair. And for sine, you just look at the y of the order pair. So sine of 30 is 1/2, because that's the y. Okay, and then here, the radian equivalent to 30 degrees is pi over 6. So I'm no longer going to be giving you these trig functions and asking you to find them from degrees. I'm going to ask you to find them from radian measures. Now, also with our special right triangles, now our side lengths on our triangle are different. So when we did the 30, 60, 90, remember we memorized the side across from the 30 was 1 or a, or 1a, and then this was a square root 3, and this was 2a. Or again, you memorized it as just the 1, the square root of 3, and the 2. However, now this r value is going to equal 1. So now all of our sides are going to change. I'm going to solve 2a equals 1, divide by 2, and my a value, this side is now 1/2. This side is 1, and then this side is going to be square root of 3 over 2. So this would be the y value in relation to the 60. This is your x, and again, this is always your r. So this is why the values are now changing, because our radius length has changed. The same thing for the 45, 45. So when you have the 45, 45, remember, we memorized these as a and a square root 2. Well, this a square root 2, this r value is equal to 1, so I have to solve for a by dividing both sides by square root 2, and a is equal to 1 over the square root of 2, rationalize, square root 2 over 2, and that's what these two sides of my triangle are, which is our x and our y. And notice in the order pair on the 45-degree angle, notice the x and the y are both square root 2 over 2. So this is why this is changing, because our radius length is now a 1. So now, the only thing that you're going to have to work for is tangent and cotangent, because you have to divide the y by x. And you're going to get your y and your x from the order pairs on your unit circle. So for example, if I wanted to do the tangent of pi over 6, tangent And pi over 6, the ordered pair, is square root 3 over 2, comma 1/2. This is x, this is y. You're memorizing tangent to be y over x. So I'm going to plug in 1/2 divided by square root 3 over 2. So back when you learned how to divide fractions, you're going to do 1/2 divided by square root 3 over 2. And if your 4th grade teacher told you keep, change, flip, stay, change, whatever it was, you keep the first fraction the same, change it to multiplication, and flip the second fraction upside down. And then you'll multiply, the 2's will simplify, and you get 1 over the square root of 3. Then you got to rationalize, square root 3 over 3. So that would be the tangent of pi over 6 is square root 3 over 3. So here's another picture. I just added a picture of a unit circle to a blank slide. So before, these angles that were on each one of the axes, this was 0 and 360. Now this is 0 and 2 pi. Up here, this top one is 90 and pi over 2. Over here, this is pi and 180. Now this could also be a negative pi or a negative 180. Up top here, this could be a negative 270 or a negative 3 pi over 2. Down here, this one is 270 and 3 pi over 2. This could also be negative 90 and negative pi over 2, depending on how you're drawing your angle. So again, remember all of the r values when we talk about the unit circle, our r is always 1. So this is why, again, sine is only y, cosine is only x. So if I ask you to find the sine of pi over 2, I'm going to find pi over 2 on my unit circle. It is up here. And the ordered pair is 0, comma 1. And sine looks at y. So this answer is 1. And then if I said do cosine of pi over 2, we look at x. And cosine of pi over 2 is 0. Now let's do 3 pi over 2. Sine of 3 pi over 2. That's the green that I highlighted. So sine looks at y, and this is negative 1. If I ask you to do tangent, let's do tangent of 3 pi over 2. Remember, tangent is y over x. So again, the 3 pi over 2 ordered pair is the 0, negative 1. So negative 1, comma 0, and this is going to be undefined or no solution. If I ask you to do tangent of pi, the ordered pair we're using for that is negative 1, 0, y over x, 0 over negative 1, and it simplifies to 0. So be familiar with where these angles are located. So for this one, again, I put a picture of a unit circle at the top of my page. So sine of 3 pi over 2, we just did this one. Remember, this is the, down at the bottom, it's the negative, or the positive 270. So the ordered pair for 3 pi over 2, which I'm going to do for all 1, 2, and 3 here, 3 pi over 2 is right here. And it's the ordered pair 0, comma negative 1. Remember, sine looks at y, so the sine of 3 pi over 2, negative 1. Cosine looks at x, and the x of that ordered pair is 0. Tangent, we got to work for, it's y over x, so my ordered pair for y, or the coordinate of the y, is negative 1 over 0. So this is undefined or no solution. Now, if it is not one of the angles on the unit circle, this is where we need to find the coterminal angle by adding and subtracting 2 pi. Now, 7 pi over 4 is on the unit circle. It's located if I zoom in here, it's located right here. Oops. My 7 pi over 4 is here. This is the ordered pair I'm going to use. So I'll go ahead and write it right above it here. So I'm using square root 2 over 2 and negative square root 2 over 2. This is x and y. Sign looks at y. So all I have to do here is, oh, and I need cosine as well. Sorry. So I'm going to use this one for both. So cosine looks at x. So this is positive square root 2 over 2. And sine of 7 pi over 4 is negative square root 2 over 2. Yeah. So if they give you an angle that is not on the unit circle, we need to find the coterminal angle to negative 5 pi over 3 by adding pi over 2 to get it to be one of the numbers on the unit circle. Now in the homework, you may have to add or subtract 2 pi more than once. For this one, I'm just going to do it one time. So I'm going to take my negative 5 pi over 3. I'm going to add 2 pi. Remember, you need to find a common denominator. My common denominator is 3. So I'm going to change 2 pi over 1 and make it 6 pi over 3. And then when I add those, my reference angle or my coterminal angle is pi over 3. All right, so now the ordered pair for pi over 3 is going to be 1/2 square root 3 over 2. And it's in quadrant 1. So what I'm going to do now, I'm doing tangent. So remember, tangent is y over x. So I have to take square root 3 over 2 divided by 1/2. So square root 3 over 2 divided by 1/2. Keep change, flip it. The 2's cancel. Simplify to 1's. And then the answer is just the square root of 3. So again, once you find that coterminal angle, you're going to grab that ordered pair and then do whatever the trig function tells you to do. In this case, it was tangent, so we had to divide. So the next two are 2 pi over 3 and 4 pi over 3. And they're both cosine. So I'm looking, both of these, I'm looking at the x of the ordered pair. So 2 pi over 3, if I zoom into my unit circle here, 2 pi over 3 is located up here. So my ordered pair is, and I'm looking at the x for cosine, so the answer is negative 1/2. So cosine of 2 pi over 3 is negative 1/2. Then I'll do the same thing for cosine of 4 pi over 3. So I need to locate 4 pi over 3 on my unit circle. 4 pi over 3 is located right here. And again, I'm doing cosine, so all I do is grab the x, and it's negative 1/2. Yep, you got to memorize it. But I'm going to... So here it says to use a calculator to find the trig functions, round to 4 decimal places. Now, remember, your calculator must be in radians. So the way that you're going to check it, you're going to do tangent of 45. You should be getting 1.6197, something like that. If you're getting 1, you're in degrees. Now, when you took the last test, your calculator had to be in degrees. This is the radian value. So now, let me go ahead and, for this one, this is approximately 1.85 radians. And again, if you think about it, when I taught this in 6.1, remember 1 radian is approximately 57 degrees. 2 radians were about here. So 1.85, it's going to be somewhere in this section here. Oops, let me fix this. Just put it in your calculator. You're going to hit the cosine button, 1.85. And you should be getting negative 0.2756 rounded to 2 places, because 1.85 radians is located in quadrant 2. And remember, in quadrant 2, when you do your all students take calculus, in quadrant 2, only sine and cosecant are positive. Cosine's negative in quadrant 2, which is where 1.85 radians is located. Then when we do the next one, cosine of 0.5149, this is like half a radian. 0.5, half. So this is located in quadrant 1, and everything is positive in quadrant 1. So when you do this one on your calculator, you should be getting 0.8703. Now tonight when you're doing the PDF of this, you're rounding to 4 places. It doesn't have it in the instructions, but round to 4 places. Now cotangent, there is no cotangent button on your calculator. So this is where we need to use the reciprocal. Now, one other thing, before when we saw this, they used either x or theta to refer to the angles. Now, sometimes what they're going to use is the variable s. So you may see cotangent of s is equal to 1 divided by tangent of s. Know that this that follows the trig function is just a variable. It can be a Greek letter, it could be a lowercase letter, it's just a variable. So in order to find the cotangent of 1.3209 radians, you're going to do 1 divided by tangent 1.3209, hit enter, 0.2552. When they give you the angle measure, and if the angle measure is negative, you are entering it in as negative. The only time you don't enter the angle in or the answer in as negative is when you're looking for the angle measure. These are angle measures, so you're entering them as they're given. So for number 12, secant, its reciprocal is cosine. So 1 divided by cosine, and you're entering negative 2.9234. And then hitting enter, and you should be getting negative 1.0243. Now, notice that the first one, number 9, the angle was positive, but we got a negative answer. The answers, the sign on it depends on what quadrant the angle is located. So if I were to graph negative 2.9 radians, negative 1 radian would be here. Negative 2 radians would be here. Negative 3 radians just before that axis. So negative 2.9 radians is located in quadrant 3. And in quadrant 3, this is where tangent and cotangent are the only positive answers. So doing a negative angle for secant should produce a negative answer when it's in quadrant 3. Then number 13, there is a button that has sign, so you're just going to push the sign button, 0.8203, and you should be getting 0.7314. Again, this is like 3/4 of a radian, or a little bit more than that. So it's in quadrant 1. Cosine, there is a button, so you're just going to hit cosine, negative 5.2825, and this is approximately equal to 5.5397. If you think about graphing this, if you were to graph it, again, this is negative 1, negative 2, negative 3 radians, negative 4 radians, negative 5, and then negative 6 would be here. So this answer, this angle, is located in quadrant 1, and everything is positive in quadrant 1. So that's why I got a positive answer. And then the last one, there is a tangent button. You're just going to hit tangent 6.4752, and the approximate answer rounded to 4 places, 0.1944. Okay, so let me show you some similarities in the unit circle and how easy it is to memorize. So if you notice, all of the coordinates, all of the ordered pairs, all have a denominator of 2. Every single x and y on my unit circle. All of the numerators also have square roots. The only difference is if you looked at this order pair here, technically the 1/2 order pair, this still had a square root of 1 here, but what they did was they simplified it and it became just a positive 1. So if when you go to fill in all of your coordinates, know that all of the denominators are 2. Every numerator had a square root, but every numerator that's a 1, they actually figured out the square root of 1. And in the unit circle, these same 3 order pairs repeat in all 4 quadrants. What you need to pay attention to is the signs of the order pairs in each quadrant. So for example, in quadrant 1, we know the X is positive and the Y is positive. So that's why these 3 order pairs all have a positive positive. In quadrant 2, the signs are negative positive. If you notice, this order pair that's here, that I highlighted in green, is exactly the same as the one straight across from it, except for the X is just negative. So the only thing that's changing is the sign. Same thing here for this one. Same order pair. Square root 2 over 2, square root 2 over 2. The only difference is the X is negative. And again, this top one is exactly the same. The only difference is the X is negative. Now, for the bottom half of the unit circle, the signs here are negative, negative, but instead of going like the red, the blue, the green, the red is now down here, and then it goes back up this way. The green is still in the middle, and then the blue is here. So it's sort of, oops, I did that opposite. So the blue is in the middle still, and then the green is here. So these are the same, except for the signs change. So it's the same 3 order pairs. The only difference is the signs on those order pairs, and then this one is positive, negative. And then when we go to find theta tomorrow, what you can look at is once you figure out your reference angle from quadrant 1, whether it's a 30, 45, or 60, looking at the denominators will help you to figure out what is the correct angle from, say, quadrant 2 or 3. So if your reference angle, let's say, is the pi over 6, then, and I wanted to figure out what was the angle in quadrant 2, I look for the same denominator. And if you notice, if you make lines and connect these, they're going to show you all of the matches. And there's different ways to memorize these. In the past, my students have looked at, say, quadrant 2. Notice the numerator is 1 bigger than the denominator, 2 over 3, 3 over 4, 5 over 6. Then down in quadrant 3, notice all of the fractions here. The numerator is 1 larger. It's 7 over 6, 5 over 4. Another thing that they found is the relationship on this one purple line that I drew here. Notice if you add 5 and 6, the numerator and the denominator gives you the numerator here. So you're not going to get that. You can go on Google, and there's all kinds of hints and tricks out there that help you to know how to fill this in.